This is us, Circle B, and we have been promoting 21-inch OCP standard in Europe. We provide OCP-based solutions for the data center. We work with partners, and then we provide usually the 4 building blocks: the rack with power, the server, storage, and networking, and we offer our own services on top of that. Why OCP? Because we believe that OCP is the next step in the evolution of the data center. Sort of for the mindset again, this is the type of companies that we're looking at. We're looking at Facebook, looking at Google, those type of innovators or early adopters. That's kind of the mindset that we're in. These are not all OCP-based companies, but just to give you an idea of which companies we're looking at. And if you're looking at the biggest tech companies, then they're all, actually 3 of them, Google, Microsoft, and Facebook, are highly contributing to OCP. Amazon building their own gear, and there's no traditional vendor in this list. Many companies, this is an example from the telcos, have faced challenges, increasing competition, increasing demand, while the revenue is decreasing, and the OTTs are eating this away from them. It was already mentioned by John Levin. Next slide is this was Google in 1999. This was their first rack. Basically, they started out from the beginning building their own gear. They never went to a vendor to buy something from the shelf. They started with this, and it's in a computer science museum now. At some point, a group of Facebook people, one of them coming from Google, also wanted to build their own hardware. So they went to Taiwan to ask us to basically talk to guys building hardware and learn how to do it. Eventually, in 2011, they open sourced the specifications, the designs, to share this, to work on this with the community, because it's not their core business to build hardware, and they think they can get more efficiency when they share this open specification. And this is the same people in Taiwan, same group. And in 2015, Niels and me and Megan, who is from Taiwan but studied in the Netherlands, we went to Taiwan to also get engaged with these manufacturers that build this hardware for Facebook. So this is us. I'm Menno Kortekaas, Technical Director of Circle B. Niels Pluimer is the Business Development Director. Megan is not here today, but as said, she is from Taiwan. She speaks the language. She's better at dealing with the culture difference with the Taiwanese people. And she is our project manager, because most of our deliveries, we see them as projects, and she manages that from the back to the front, basically from the supplier to the delivery to the customer. As we've seen, OCP is what we call a rack scale architecture. It's just they start with one rack and then multiply that. As you can see here, all these racks, they actually have the same layout. They look exactly the same. And that's multiplied out into different pods to the back of the room. It's very modular. For example, we see the rack as a module, and then we see the power as a module, power shelf. The server, so this is a server up here inside, and you've seen one like it here and downstairs. And the storage component, they are all cabled together. Actually, the modularity goes even deeper than that. You could exchange a board like this one. This is a SAS expander, and you could exchange, for example, a 6G SAS expander for a 12G SAS expander for easy upgrades. Or when a component fails, it's very easy to replace it. It's all serviceable from the front. No need to really be at the back of the rack. It's also all hot swappable. That's what we like about the Facebook OCP standard. That it's kind of something that everyone can adopt, because you can exchange just simple hard disk components as a hot swappable component. It's toolless, as John explained. No tools required. All the green points are touch points, and that's it. You really can do all the maintenance, all the replacement without any tools. There's a lot of innovation in OCP, specifically by Facebook. As you notice, this is a Rittal rack in the Facebook lab, and yeah, they develop and test all these components there at Facebook. I think the cycle is much faster than what you see from a vendor. They already have, this is the third generation of their server type, and it just goes on and on. The web scales, they like this because they always tend to like open source things. And of course they have fewer applications than a typical or large enterprise. And it allows them to scale out. I've placed here some different rack layouts. What Facebook does is that, as you saw in the photos, they multiply these racks. So it could be maybe 60 of this first compute rack, and it's really huge scale. But we could also make this much smaller. We could have a rack that has some compute here and some storage in the middle and something else at the top. It's all very easy to swap this out and customize this to your needs. So it's not only for the web scales. And then you just scale out to the next rack. We think this is also good for clouds, especially if you use automated provisioning. It's very easy to scale out, deploy another rack, and automatically provision it. As you can see, these technologies like OpenStack, they run on standard hardware. And then our building blocks, compute, networking, and storage are on top of that. But it's standard hardware, so it doesn't really matter if it's a branded hardware or the hardware that we provide from OCP. And then your many applications can be on top of this. Telcos also tend to move to OCP because of the network function virtualization. So all these boxes on the right side, they're all going to be moved to a virtual instance running on somewhere inside OpenStack or any other type of cloud. Cord was already mentioned. Mano is actually a management and organization working group of ETSI, and that's a framework for NFV. So you could look it up later. The slides will be shared. And Telecom Infra Project is actually a sort of a spin-off of OCP, specifically by the telcos, because there were so many telcos doing this and contributing. They started their own working group. Also very interesting to follow this. We think that if you would like to compete against a public cloud service, then what you need to do is run this on open source software, open source hardware. We think that this is really the way you could compete against these public cloud providers. So then our next building block is the data center. This is actually something totally new, but there's a a document is still being worked on is the co-location facility requirements document. I thought this was interesting because you can all view the document and see if this applies to you, or if you have to maybe change something in the future, or if you're planning a facility, then will be good to follow this. It's from the Open Compute mailing list, and Mark Dancy is leading this. He's in the UK. John knows him well. It could be interesting for you guys just to follow this mailing list if you would like to have more information. As I said, this is very early draft document, but this is coming and could be interesting. We have been working with a data center in Amsterdam, Switch Data Centers, which has already implemented a lot of these criteria. For example, they can manage the height of the rack, the weight of the rack. They have hot corridors, which is something that's preferred in OCP. So we've been working with them, and they're now ready to basically adopt our house OCP. So the Open Rack was already discussed. Here is another picture. It's something that we also provide as a product. And then we have the Open Server, which is laid out here. We work with WeWin, and WeWin is one of the manufacturers for Facebook. They also make all the storage products for Facebook and these servers here. It is a key supplier for us. We work very closely with them. We think it's important to work with them and maybe not with another manufacturer, because they work so closely with Facebook, and we can really see, for example, when we talk to them or visit them, we can see which products are coming and are not even on the mailing list or not even being discussed. We can already see where it's heading, and we can also know what this hardware is being used for, what was the use case, or why did they build it, what are these small details for. So that's why we work with very closely with WeWin.
The big hardware vendors,
yeah,
like Dell, ABM, HP, they buy the equipment there.
Well, WeWin is a spin-off of Wistron. And Wistron is a manufacturer that manufactures for Dell and HP, etc. But they do this under a strict NDA, so they're not allowed to talk about what they're doing. And WeWin actually is created specifically for promoting or advertising. They have a website, you can see all the products. They're exhibiting at exhibitions, and you can see what they're doing. But all the other, like John also mentioned them, in last year, he mentioned Quanta. Foxconn is well known. Wistron then is a bit smaller, but they're not allowed to talk. If someone sometimes leaks out what the new iPhone will look like, then, but that's all highly illegal. So they're not allowed to talk about what they build. But WeWin is created specifically to be in the public and to sell these products to others, because that's what Facebook wants. That's why they started OCP. So they also convince these manufacturers to have a public part. That's why we went to Taiwan to visit them in early 2015. As said, we promote the 21-inch standard. Now there are also other products such as the 19-inch kind of OCP inspired. They have some of the same components that you'll see on this server, the same BMC mezzanine slot, some similarities. And they also built Microsoft OCS. It was briefly mentioned as well, which we don't really promote because we haven't seen any adoption, and we think it's purely built for Microsoft, but you could get it if you want. If you want to adopt that standard, it's available. It's possible. But we see more of a future in 21-inch because of the modularity, and more equipment fits inside, and it's a heavy adoption going on of 21-inch. So this is the Facebook server. Well, you can all have a look here. Two CPUs. Facebook uses this 3.5-inch hard disk, but we have also different mechanical configurations which just change. They can change it by just installing a different part here, just a mechanical change. 16 DIMM slots, M.2 or M SATA on board, and well, this one, the riser card is missing, but 2 or 3 PCIe slots. And there's an OCP mezzanine slot inside, and you can install, one server downstairs has an OCP mezzanine card. You can install a single 10 gig, such as Facebook is doing, or dual 10, 25, 40. There's a new standard coming in the next generation for 100 gig network cards. And they also, the mezzanine cards can be used, for example, in the 19-inch server. There are several manufacturers that make these cards, such as Mellanox and Intel. As you've already seen, it has large fans, but also the heat sinks. They are the same height as so the 2OU height, which is also beneficial. And you can see no logos, no bezels. It's built to open specification. You could go to the OCP wiki page. You can download these specifications. A lot of information there about how it's built, and it's sort of half user manual as well. But anyone here can just have a look at them. They're on the website. This is the cubby that it sits in. This is quite a recent change. But when you want to have a new CPU in your data center, when you want to start using the next Intel generation, you just move out this part. The cubby stays inside, and the cubby connects to the central single bus bar. So that's a new change as we've seen in the racks. It's all moving to a single bus bar. And so that's why we have the cubby, which can be seen in downstairs. We make sure that these servers are tested and certified. So this is the CE certification. Facebook also has their own, for example, an oven and all. They do a lot of tests themselves. But we also have these documents. This is ROHS compliance. So they are certified. They can enter the EU, and we can use them. The open storage, also seen in downstairs. Different versions. I think in total there's about 5. There's 6G SAS, 12G SAS. There's the one with the storage server downstairs. Has a small server on top. And that one is also in downstairs. This is called Lightning. This is all NVMe, flash, all flash. The one in downstairs is an engineering sample with a red board. They're based on the same mechanical design as John already showed, but there's some components that you can change. So it's easy to, for example, upgrade from to a new, for example, from 6G to 12G SAS. Just replace the board, and there's your upgrade. My background is networking, so I have a bit more slides on networking. Don't know how far we are on time at the moment. Okay, 20 minutes. So these slides will be available. But there's been a big movement in white box bare metal switching. And I would like to tell a little bit more, because this is the most easy to adopt, because it's all 19-inch. So you don't actually need to start with the rack. You can get that one later. 3 choices that you have to make is the silicon, the ASIC, which manufacturer you prefer, and the operating system. Because networking is all based on standards. The internet wouldn't work today if there were if nobody kept to the standards. So that's what these manufacturers are doing. They just keep to the IP, for example, is a standard. All network devices work with IP. So it's very easy to start removing vendor lock in here. This is an early design of a Facebook wedge switch. You can see here is the location of the ASIC. Then there's a CPU inside, small Intel CPU, and it runs some software on top. So for silicon, there are basically two manufacturers, Broadcom and Mellanox, and they have different features per chip, different speeds. Also, currently coming is deep buffer switches. The Qumran and Jericho stuff is coming, and this is going to really disrupt basically the higher up market of switching. These Broadcom chips, they're already being used by many existing vendors. You can see Cisco, HP, Dell, everyone is using these Broadcom chips, and we're going to talk a little bit more about this part, because this is what we do, is the open stuff. So several manufacturers to choose from. Actually, there's a lot. We work with Acton or EdgeCore, who also build the Wedge 40. We work with Ajima as well, who are now building deep buffer switches for various ISPs, telcos. And Mellanox is more, they came from the high performance compute side, low latency. And they also make the OCP mezzanine network cards. So for the operating system, the OCP Foundation has their own bootloader called ONI. And when you buy a switch, the first thing it does is look for the operating system. So it looks at USB stick or a web server to download its operating system. And it starts to install the operating system of your choice, which could be, for example, Cumulus Linux, which makes kind of the switch look like a server. It's a full Linux installation. And yeah, you can run all your applications that you're running on Linux on the switch itself. Manage it in the same way with Puppet or Chef. On the other side, we also have IP Infusion, Ognos, for example. They are in networking for 15 years, but nobody knows them. They're in F5 and Citrix NetScaler. They're the builders of the old Zebra BGP daemon, which in network world many people know, but they don't know that it was built by them. And they are more for ISPs. They have an industry standard CLI, so it looks like Cisco CLI. And more into the routing part. The typical network that you build with OCP gear will be the CLOS Fabric. So this is a 5-rack example. It doesn't have to be huge. You can start up with this, but it's basically a switch chassis spread out into different switch products with a core to exit the network. And this scales. This can go up to, this is Facebook scale. And yeah, so you can use this in a small data center and a big data center. So now about the services that we provide. Our mission is to help you not to pay for what you don't use, while increasing efficiency and scale using open source components. Some of the services that we provide, but we could design, help you to integrate, cable it all up. We can do this in Asia or in Europe. We can do burn-in tests, make it ready for automated deployment. For example, give you a list of MAC addresses of the servers so that you can type in, okay, this server is going to be a database and this server is going to be a web server. When you power it up, it all installs as you have set in the template. And we also offer various support services. This was almost the end. I went quite fast, I think. I wanted to give this to you that if you want to look at this, if you want to start back at the innovation and go up, this is what you have to look at. Software-defined automation, running on bare essentials hardware, adopt a rack scale and scale out from that. And that allows you to compete against public cloud. You could start with switching, and we are here to help. You don't have to do this alone. And that's it. You can find us on social media.
Okay, thank you.